Welcome to an introduction of trigonometry. For trigonometry, you will be given a right triangle in this course. You can use trigonometry for non-right triangles, but using law of sines and law of cosines, but for this class we're really only going to work with trigonometry using right triangles. So you'll be given a right triangle, and you'll also be given a reference angle. And a reference angle is the angle that you're focusing on for that trig function. It's your identities, and these laws that we're about to get to are going to be different depending on which is your reference angle, whether it's maybe this one here or this one here. So in this example, I've labeled this as my reference angle, and it will oftentimes be labeled as theta. This symbol right here is the Greek letter of theta. Sometimes it might be an x or y or a more familiar variable, but it might also be theta. So let's start to work with theta. From your reference angle, the leg across from it is the opposite leg. The leg adjacent to it is your adjacent leg. And of course, the hypotenuse is still the hypotenuse. You'll notice the hypotenuse is also adjacent to theta, to our reference angle, but it's not an adjacent leg. So these legs get special words for opposite and adjacent. Hypotenuse is still the hypotenuse. There are three trig functions: sine, cosine, and tangent. And really, for this level of geometry, we don't need to know too much about them, except for what sort of ratio they're going to equal. So for sine, abbreviated SIN, the sine of theta is going to be equal to the ratio of the opposite leg over the hypotenuse. Maybe this is 2 and this is 5, in which case this would be 2/5. So let me go ahead and add in some numbers just to make this seem a little more tangible. So let's say that this is 2, this is 4, and this is 5. So again, the opposite over hypotenuse, this would be equal to 2/5. The sine of theta is 2/5. The cosine of theta, abbreviated COS, is going to be equal to the adjacent leg over the hypotenuse. So in this case, that would be equal to 4/5. The tangent of theta, abbreviated TAN, is equal to the ratio of the opposite leg over the adjacent leg, or 2/4 or 1/2 if I wanted to reduce. So the way that kids learn this, and the way I learned in high school, and everyone around the world remembers it, is by the name Sohcahtoa. Sohcahtoa, meaning sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is opposite over adjacent. So the order of these letters is always going to go trig function, followed by numerator, followed by denominator. So trig function sine is equal to the numerator opposite leg divided by my denominator, the hypotenuse. So pretty much this just needs to be memorized. It really does, because then you can just apply it to all different types of triangles. There are a few different ways to use trig, and a few reasons why we would want to use trig. You might be given an angle and a side of a triangle, and you will want to know a side. You can use trig to do that. You might be given two sides of a triangle, and you might want to know the angle. I have a star here and an arrow towards inverse functions, because these ones are a little bit different than the ones we saw before, only in terms of what we plug into the calculator. So I'll show you that in a second. So again, this is an example of number 1. I might be given a side and an angle and asked to find what's the hypotenuse. In this example, I'm given two sides, and I'm asked to find what is that angle. What's x? It might also be labeled theta. So let's run through one example for each of these types of problems. So in this example, I'm given a building. And here's my building here, and I'm given a side and an angle, and I want to know the side. So this is an example of the first category we saw in the last slide. I got a building, I have my angle, so maybe a person standing here looking up at a 55-degree angle. I know the distance from that person to the building is 57 feet. How tall is the building? So first, let's find h. So always label what is your reference angle. So this is our reference angle. From there, which is our opposite, adjacent, and hypotenuse. So opposite, this is going to be our opposite leg. Our adjacent leg is going to be next to it, and our hypotenuse is always the hypotenuse of a right triangle. Okay, so now I can see which trig function do I want. If I use sine, I would have sine of 55 is equal to h over L, because they're both variables. That's not really going to help me out. I only want one variable. So let's see. Let's think about it again. We have Sohcahtoa. Which one is not going to use opposite and hypotenuse? Because I only want one. And in fact, I only really want my opposite. I don't want to include my hypotenuse right now, because right now I'm trying to find the height of the building. I don't need to know this at all. So I definitely wanted to involve O and A. O, OA, TOA. Okay, so let's use tangent of theta is equal to TOA, opposite over adjacent. I'm abbreviating opposite and adjacent as O and A. Now let's plug in some of our numbers. We know theta is 55 degrees. So tangent of 55 degrees is equal to opposite. In this case, that's labeled here as the height of the building, and that's still a variable. I'll leave it as O. A, however, we do know the distance of this adjacent leg, and it is 57 feet. From here, I would take my calculator and I would type in tangent of 55, and I would get some number. To get O by itself, right now it's being divided by 57, so I would multiply 57 feet on both sides times 57 feet. That way, when I get 57 times the tangent of 55, this will go away, and I'll just end up with what is that opposite side. So that would give me just this height of the building alone. What if I now wanted to build a ladder that went from the top of this building down to where this person was standing? How could I find what L is here, what the hypotenuse is? How could I find that? So now I could, once I type this into a calculator, I'll have O. So I could use O with H or A with H. Since I haven't typed it into a calculator, let's find the one that uses A and H. Sohcahtoa, C-A-H. Okay, so we have cosine of theta is equal to Sohcahtoa A over H. So we have cosine of theta is equal to our adjacent leg over the hypotenuse. Cosine of theta, let's put in some numbers. Cosine, our reference angle theta is still the same, 55 degrees, is equal to our adjacent leg. Our adjacent leg is 57 feet divided by H, which is our hypotenuse. Here, to get H by itself, I need to do some algebra. If I had a calculator and could find this number, it would be simpler. But essentially what I'm going to have to do to get rid of it in the denominator is multiply this side by H and this side by H, like I did up here. Now I'm going to end up with H cosine of 55 is equal to 57 feet. 57 feet. The problem is H is still not by itself. H and cosine of 55 are being multiplied. So if I want to get H by itself, I need to divide each side by the cosine of 55. And the reason why I'm going to do this, and again, here's just algebra skills, because now cosine 55 divided by cosine 55, that goes to 1. So now I have H, the hypotenuse, or L as I've labeled it here, is equal to 57 feet divided by the cosine of 55. And as soon as you're on your calculator, you can go ahead and plug this in, and you'll get what that h is. So I could find it up here, and the math might be a little bit easier, but I don't have to actually find it until the end, because I can put it in right here and find h. So from these two expressions, we would have found tangent of 55. I believe we had 57 here. 57 times tangent of 55 is equal to this side right here, and 57 feet divided by the cosine of 55 is equal to that distance there. So this was an example of given a side and an angle where we want to know a side. But what if we are given two sides and we want to know an angle? This one gets a little trickier. So here I have a flagpole, and I know the height of the flagpole and I know the length of its shadow. What I don't know is the angle of the sun. Maybe I'm trying to figure out what time of day it is. So I have a sun here. It's hitting this flagpole, casting this shadow onto the ground. I have to assume that the ground is flat, making this a right angle. Again, always label what is your reference angle, which is your opposite side, your adjacent side, and your hypotenuse. So this is our reference angle. This is the angle we're trying to find. Even if this weren't labeled here, I could still find that as my reference angle because that's the angle of the sun. This angle right here is the angle that sun's kind of hitting this flagpole, but you want to hit it. The angle of the sun is where the sun rays hit the ground. So we have our reference angle here. We have our opposite leg, our adjacent leg, and our hypotenuse. Hypotenuse is always the hypotenuse, no matter which reference angle. So here I have, and I'm trying to find what this angle is. So which trig function is going to involve the opposite leg and the adjacent leg? Sohcahtoa. Toa. Okay, that involves them both. So tangent. We need the tangent of theta is equal to opposite over adjacent. Toa. Alright, so let's fill in some numbers. We don't know what theta is, but we know that the tangent of theta is equal to opposite, which in this case is 60 feet, over adjacent, here is 45 feet. Of course, I can reduce this, because for all similar triangles like this one, like maybe I have a smaller flagpole or a building, but it's the same time of day, so the angle ray will hit it at the same angle, all those would make similar triangles. And that's how we found the height of this flagpole before, by using similar triangles. So I could reduce this. I could definitely say that, alright, I notice that 15 goes into both of these. It goes in here 4 times, and it goes in here 3 times. So the tangent of theta is equal to 4/3. My theta is going to be the same if this were 4/3 or if this were 60/45. It's because there's similar triangles. So now, tangent of theta. We know from algebra if tangent was being multiplied by theta, or if these things were being multiplied, we would divide to get rid of it. Unfortunately, tangent in itself is its own function. It's its own operation. So we can't divide, we can't do any of the ones we know. But it also has an inverse. Just like division is the inverse of multiplication and addition is the inverse of subtraction, these functions are the inverses of our trig functions. And you'll see these little negative ones up here, which means raised to the negative 1 to the negative first power, which essentially means that sine the negative 1 like this is equal to 1 over sine. So this is what we're going to use in order to get rid of this. Because if I have tangent and I multiply it times 1 over tangent, now I can cancel those two out. So that's what I'm looking to do here. So if I have tangent, what I need to do to get it out of here and get theta by itself is take the inverse, tan inverse, and now that moves over to this side, and tangent gets left alone. So it becomes tan inverse of 4/3, and that is what's equal to theta. Same with sine and cosine. If the function we had chosen to use here were sine or cosine, again we would just do the same thing, where we would take the inverse function. On the calculator, the inverse function, if sine is the main function, that when you hit the second key, you'll get the sine inverse. So if you want to put in a sine inverse function, you hit second and then sine, and then you put in the ratio of the sides, and it will give you the angle. So a little tricky on the calculator, but just think about it the same way as we've been doing algebra problems, where if you have multiplication, you need to take the inverse, which is division, to get rid of it, to move it over to the other side. Same thing here, and it's just a little bit different, and we have a special button for it on the calculator. So again, in this video, you learned some of the basics of trig, and we're going to practice because these problems are just applying the same idea over and over and over, and trickier and trickier word problems. But the math itself, not too difficult. We have sine, cosine, tangent, and we have two ways that we might want to use it. Our first example dealt with when we were given a side and an angle, trying to look for another side. Here we're given two sides, we want to know another angle. You might be thinking, why don't we just use similarity to do this, because that's what we've been doing. We need to know less information here to solve for problems than we would with similarity. Also, similarity, a lot of times we have to use shadow problems. What if it's a cloudy day?